The optional calculation method, specifically Section 220.82 of the National Electrical Code, can be applied to feeder loads even when the calculated ampacity is less than 100 amps. The critical factor is the ampacity of the conductors serving the load, not the calculated load itself. Section 220.82 states that the optional calculation method applies to a total connected load served by a single set of service or feeder conductors with an ampacity of 100 amps or greater. This statement focuses on the conductor size, not a minimum calculated load. To illustrate, consider a scenario where a subpanel is wired with conductors rated for 100 amps. Using the optional calculation method, the resulting load calculation is 65 amps. In this instance, the subpanel is considered adequately sized according to the optional calculation. The code mandates that the feeder conductors possess an ampacity of 100 amps or more to qualify for the optional calculation method, but it does not stipulate that the final calculated load must equal or exceed 100 amps. One of the main benefits of using the optional calculation method is that it often yields lower amp demand calculations than the traditional calculation methods. This difference can lead to several advantages. Firstly, more efficient utilization of electrical resources. Secondly, potential savings on material costs because smaller components may be adequate. And thirdly, reduced installation expenses due to the potential for using less bulky wiring and equipment. To summarize, the optional calculation method can be used to determine the feeder load on a 100 amp subpanel, even if the calculated load falls below 100 amps. Compliance with the National Electrical Code hinges on using conductors with an ampacity of 100 amps or higher. Now let's delve into why the National Electrical Code permits this approach. The optional calculation method takes into account the diversity of loads within a dwelling. It recognizes that not all appliances and electrical devices will operate at their maximum rated current simultaneously. For instance, it is unlikely that the electric range, the clothes dryer, the air conditioner, and all the lighting circuits will draw their full rated current at the exact same moment. The optional calculation method applies demand factors to various types of loads, reflecting this diversity. Demand factors are multipliers less than 1.0 that reduce the calculated load to a more realistic estimate of the actual demand. These demand factors are based on statistical data and engineering judgment. For example, the National Electrical Code provides different demand factors for ranges, depending on their rating and the number of ranges installed. Similarly, demand factors are applied to heating and air conditioning loads, as well as general lighting and appliance loads. The specific demand factors used in the optional calculation method are detailed in Section 220.82 of the National Electrical Code. Understanding these demand factors is crucial for accurately applying the optional calculation method. Now, let's compare the optional calculation method to the standard calculation method. The standard calculation method, outlined in other sections of Article 220 of the National Electrical Code, typically involves adding up the nameplate ratings of all connected loads and applying relatively conservative demand factors. This approach tends to result in higher calculated loads compared to the optional calculation method. The standard calculation method is generally more straightforward to apply, but it can also lead to oversizing of service and feeder conductors, resulting in increased costs. The choice between the optional and standard calculation methods depends on the specific characteristics of the dwelling and the preferences of the electrical designer or contractor. The National Electrical Code permits the use of either method, as long as the resulting service or feeder conductors are adequately sized to carry the calculated load. However, it's important to note that some local jurisdictions may have specific requirements or restrictions regarding the use of the optional calculation method. It is always recommended to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Let's look at a practical example. Consider a single-family dwelling with the following electrical loads: a 12 kilowatt electric range, a 5 kilowatt clothes dryer, a 3-ton air conditioner, 1500 square feet of living space, 220 amp small appliance circuits, 120 amp laundry circuit. Using the standard calculation method, the calculated load would be significantly higher than using the optional calculation method. The optional calculation method would take into account the diversity of these loads and apply appropriate demand factors, resulting in a lower calculated load. This lower calculated load could potentially allow for the use of smaller service and feeder conductors, as well as a smaller service disconnect. However, it is crucial to carefully consider all factors before making a decision, including potential future load growth. It is always better to err on the side of caution and provide adequate capacity for future needs. Now let's discuss some common misconceptions about the optional calculation method. One common misconception is that the optional calculation method is only allowed for dwellings with a certain square footage or a certain number of occupants. This is not true. The optional calculation method can be used for any single-family dwelling, regardless of its size or occupancy. Another misconception is that the optional calculation method is only allowed for new construction. This is also not true. The optional calculation method can be used for both new construction and existing dwellings as long as the existing electrical system is in good condition and meets all applicable code requirements. A third misconception is that the optional calculation method is somehow less safe or less reliable than the standard calculation method. This is also not true. Both methods are designed to ensure the safety and reliability of the electrical system. The choice between the two methods is simply a matter of engineering judgment and cost considerations. It's important to note that the National Electrical Code is not a design manual. It is a set of minimum safety standards. Electrical designers and contractors are responsible for ensuring that the electrical system is not only code compliant but also meets the specific needs of the dwelling and its occupants. This may involve exceeding the minimum requirements of the National Electrical Code in some cases. For example, it may be prudent to install larger service and feeder conductors than required by the optional calculation method to provide for future load growth or to improve voltage regulation. Voltage regulation refers to the ability of the electrical system to maintain a stable voltage under varying load conditions. Poor voltage regulation can lead to dimming lights, malfunctioning appliances, and other problems. Larger conductors have lower impedance, which helps to improve voltage regulation. In addition to considering future load growth and voltage regulation, electrical designers and contractors should also consider the impact of energy efficiency measures. Energy-efficient appliances and lighting fixtures can significantly reduce the electrical load on a dwelling. This can potentially allow for the use of smaller service and feeder conductors. However, it is important to carefully evaluate the energy efficiency measures and their potential impact on the electrical load before making a decision. Now let's discuss how to properly apply the optional calculation method. Firstly, gather all the necessary information about the dwelling, including its square footage, the rating of all appliances, and the number and type of lighting fixtures. Secondly, refer to section 220.82 of the National Electrical Code to determine the appropriate demand factors for each type of load. Thirdly, calculate the total connected load for each category of load, such as general lighting, small appliance circuits, and electric ranges. Fourthly, apply the appropriate demand factors to each category of load to determine the demand load. Fifthly, add up the demand loads for all categories to determine the total demand load. Sixthly, select service and feeder conductors that are adequately sized to carry the total demand load in accordance with the ampacity requirements of the National Electrical Code. Finally, verify that the service and feeder conductors are protected by appropriately sized overcurrent protection devices such as circuit breakers or fuses. Overcurrent protection devices are designed to protect the electrical system from overloads and short circuits. It is important to select overcurrent protection devices that are properly rated for the ampacity of the conductors they are protecting. Undersized overcurrent protection devices will trip prematurely, while oversized overcurrent protection devices will not provide adequate protection. In addition to the optional calculation method for dwellings, the National Electrical Code also provides optional calculation methods for other types of occupancies, such as schools and restaurants. These optional calculation methods are designed to simplify the process of calculating service and feeder loads for these types of occupancies. However, It is important to carefully review the specific requirements of the optional calculation method for each type of occupancy before applying it. Let's briefly discuss some other relevant sections of the National Electrical Code. Section 210.19 provides requirements for the minimum ampacity of branch circuit conductors. Section 215.2 provides requirements for the minimum ampacity of feeder conductors. Section 220.3 provides general requirements for calculating branch circuit, feeder, and service loads. Section 230.42 provides requirements for the minimum ampacity of service entrance conductors. Section 240.4 provides requirements for the protection of conductors against overcurrent. These sections of the National Electrical Code are essential for ensuring the safety and reliability of electrical systems. It is important to be familiar with these sections and to apply them correctly. In conclusion, the optional calculation method is a valuable tool for electrical designers and contractors. It can simplify the process of calculating service and feeder loads for dwellings and can potentially lead to cost savings. However, it is important to carefully apply the optional calculation method and to ensure that the resulting electrical system is safe and reliable. Always consult with the local electrical inspector to ensure compliance with all applicable codes and regulations.